Assalamualaikum. Today we will be presenting about our open-ended lab which we choose is question 1.
I would like to introduce my group members and their contribution. This is Lipein, Fateha and myself Kavinesh, and our contributions are stated below.
These are the two objectives of our open-ended lab. The function of this circuit covers a 0 to 5 volt input signal into the 0 to 10 volt output signal. It used to increase the voltage level of a signal of a system that require high voltage range. Our design uses a 741 op amp in a non-inverting amplifier configuration. The required gain was calculated as 10 volt output divided by 5 volts input. We selected using RF of 2.2 kilo ohms and RI of 2.2 kilo ohms. The circuit power using is 12 volt DC supply. And the schematic diagram was shown as above.
These are the component and the costing that we use to make this circuit. And this is the waveform simulation in the multisim.
For the timeline, we firstly started with the research basics of signal conditioning and op-amp configuration. Then we proceeded with component selection for our circuit designing. Then we draw the circuit using multisim software. Then documentation of all schematic and simulation results were done. And finally, we did the simulation at the lab.
The circuit was connected as shown and the power is turned on.
The voltage between plus and minus input of the op-amp was measured and recorded. Values of RI and RF were measured and recorded.
The signal generator was set to 1 kHz and 5 volt peak to peak at the input of the circuit. Those were turned on.
An oscilloscope was used to measure and observe the input and output voltage along with the waveform.
The input and output voltage were measured using multimeter.
For the result, we used input voltage of 5 V peak to peak, and our expected output was 10 V peak to peak. The simulation in multisim shows a 10 V peak to peak output, and our measured output was also similar, which is 10.8 V peak to peak.
For the discussion part, the simulation result matched the expected output by producing 10 V peak to peak, which confirmed that the circuit was correctly designed. The voltage gain was calculated using formula voltage gain is equal to V out over V in. The waveform and its phase for both simulation and real-life application shows as expected without any distortion. The measured output was 10.8 V peak to peak, which slightly differ from the expected output. The slight difference might be the effect of real-world factors, which are component tolerance.
For the conclusion, the objective of the lab were successfully achieved. The waveform analysis using the oscilloscope in multisim confirmed that the design of amp circuit amplified the input signal ranges from 0 to 5 volt into output range of 0 to 10 volt. The practical demonstration further validated the design, showing consistent result in both simulation and real measurements. This lab enhanced our understanding of op-amp application in signal amplification and level shifting.
For the reflection, this lab helped us improve our understanding of signal conditioning and how to choose appropriate resistor values for gain control.
We found the hands-on experience with the oscilloscope and signal generator especially useful in reinforcing the connection between simulation and real-world output.
We appreciated the teamwork and learned how to organize tasks effectively within a tight timeline, while also improving skills in report writing.
These are the references we used for this open-ended lab. So that's all from us. Thank you.
Thank you.